Very good morning, students. Today we are going to discuss about the classification in supervised learning. Here before we have discussed the regression, the types of supervised learning. We already knew that what it is, classification and regression. So classification, we need to discuss logistic regression, and it is a type of linear classifier, and SVM, that is support vector machine nonlinear classifier, and KNN, that is K nearest neighbor non-linear classifier. And here it is linear and non-linear. We could understand that linear in the sense, if input varies, the output also varies. That is, the output depends upon the input, because we can call the output as a dependent variable and input as the independent variable, right? So this is how it is named as a linear classifier as well as the non-linear classifier. And coming to the regression, it is linear regression, and we are going to discuss about the linear regression. This linear regression we have discussed in the previous class itself. We'll discuss in detail about classification in this slides. And what is meant by classification? In the classification, it comes under the supervised learning. That is the one, it's a one type of problem we are going to deal in the supervised learning of machine learning process. And classification is a key task in machine learning that involves predicting discrete categories or labels for data points. That means what? Discrete categories in the sense, discrete in nature, it is not continuous. That is, either it may be a 0 or 1, that is high or low, or yes or no. This is how the discrete categories is to be, right? And it is a fundamental type of supervised learning, where the algorithm learns from labeled data set to make predictions on unseen data. This is the important character here. And classifications models are widely used to solve real world problems like what email spam detection and diagnosis, that is disease diagnosis and image recognition. So this in these fields, this classification problems plays a vital role in our day to day life applications. Okay. And coming to the so that is supervised learning types, we have already discussed, that is linear regression and logistic regression. So linear regression, the curve response, it should be linear, and the response, you see the image of the curve, the response is non-linear. That is, when input changes, the output is varied, it is not linearly increased or decreased. So that is why it is called non-linear, right? And coming to the classification, we are going to discuss, the first thing is logistic regression, because in the previous slide we have seen what comes under the classification: logistic regression, SVM, that is support vector machine, and K nearest neighbor. And in this video we will discuss in detail about logistic regression. What is logistic regression? So the name itself, we can come to analyze logic in the sense, here it may be 0 or 1, that is the logic state if we used to be in the digital, right? So it predicts the probability of binary outcome. Binary in the sense 0 and 1, that is we can call it as bits, that is binary digit. And yes, no, or 0 or 1. Use the sigmoid function to map inputs to probabilities. So either it may be a probability of a 0, or it may be a probable of occurrence of 1, and ideal to classification task. And you will just see this image, that is here input features are there and linear combination, then we can have either class 1 or class 0. This is how the logistic regression takes place. And types of logistic regression, here we have the three types of logistic regression, that is binomial and multinomial and ordinal. What is binomial? Bi in the sense 2, so it is two classes, that is 0 or 1, either it may be a 0 or 1, that is why it is binomial. And multinomial, multi, more than 2, right? So more than 2 unordered classes. So here the main term we need to listen is unordered. That means what? Cat, dog, sheep. These images is mentioned, but it is not categorized or ordered. The first, the dog image should come or cat image should come. Likewise, it is not order. Okay, that is why it's generally called it as a multiple images multinomial. And ordinal, so the name itself, it is ordinal. That means what? Ordered manner, right? So more than two ordered classes, that is here it is low, medium and high. So how the low, medium and high? The low must come first, or medium the second, and high should be the third. Likewise, it should be in a ordered way. So these are the types of logistic regression. that is binomial, multinomial, and then ordinal, right? And logistic regression types I have explained in detail in the last slide itself. So here binomial, we'll see this type is used when the independent variable has only two possible categories. Example include yes, no, pass, fail, or 0 and 1. It is the most common form of logistic regression and is used for binary classification problems. Yes, it is mainly used for binary classification problems. Multinomial logistic regression, this is used when the dependent variable has three or more possible category. That is dependent variable here what they mentioning, that is the output. Okay, so the output must be a dependent variable. Categories that are not ordered, for example classifying animals into categories like cat. So last image we have mentioned this explanation. And coming to the ordinal, so here low, medium, high as took as a example. Okay, so this is how the logistic regression types takes place. And how does this logistic regression work? So you just see this image here. Here the x is the matrix of input, how many inputs we are making. It may be a bi or multinomial or ordinal. And y in the class, it is going to be determined either a 0 or 1. If it is 0, it is a class 1, or 1, it is a class 2. This is how the logistic regression works. It's going to be takes place. The detailed explanation video link I have given here, you may refer the video link for your further references. Okay, so still now we have discussed about logistic regressions. Thank you for your passion listening.